Hello, this is Brandon Etchison, and I'm giving my final presentation on predictive reliability maintenance with Arduino and Azure. Probably familiar with my project. I'm recording it via my phone because I was having some other issues, so hopefully this is okay. The quality isn't going to be as good as what I had hoped. So I'm going to just jump into my presentation. I have the same picture that I've thrown up every single time. That's my solution architecture. We're going to go through the beginning all the way to the end, the Arduino, and all the way out to the Windows Phone. So with that said, I'm going to jump into the demo. I'm going to jump down here real quick. I have my Arduino. I have the Bluetooth sensor. I have a light indicator to just show that it's gathering data. That's the Arduino. I have a battery out here with a connector here for the motor, and I have the accelerometer attached to the motor. So it seems like I'm getting some type of interference right now when I connect the battery over there with the motor and everything that's going on here. So I'm going to hold off on that until later on in the presentation. So, but that's that. Here I have my console app. So you can see it's reading data right now. Console app is running on my desktop, my laptop, connected via Bluetooth to the Bluetooth sensor right there. And that's how it's getting the data. So what's happening, can't get it in there very good right now. But what's going on here is, there we go. So what's going on here is you can see all the data points are pretty close. It's X, Y, and Z. The data is all pretty close because it's not sitting. It's just sitting there idle. It's not, and you can see like the changes are just minuscule changes because I have a not a very precise accelerometer. I'm getting differences, and the differences are showing up a lot larger than they should be. So even though you see your data there, like it's 0.01 is really the smallest change I can have, and that's a limitation of my accelerometer. But that's this accelerometer interacting with the console app. So if we jump in and say, okay, let's talk about where does it go there. So data is getting captured here, it's getting sent to the console application, and I've disconnected the Arduino for now, so it's not sending a bunch of data. But here it's sending the data out here. It's capturing it. The console app is then initiating HTTP requests to a service I have in Azure, and then that is getting processed. So if we kind of jump into that, what that looks like, I have what I kind of use to prove that out or show that is I had some queries I've written here in Visual Studio. The vibration data, that's the first thing my service does when it captures it. If I execute it, I should see several data points change. You can see all those data points change, and then I calculate the velocity, and then I have the date there. So every 30 seconds it was going. So that tells me that it's going to the service. The machine learning data is basically when the data has been, or when the service has taken the data and processed it, it's saved it to the vibration data table. It then sends it to machine learning service, and then gets the data back, and then stores the machine learning data in this machine learning data table. If I look in there, you can see right now, we're getting results. It says this is what it predicted. This is what the actual change was. You can see that my deviation here is 0.01, I believe. That's how much it needs to change, be a difference between the two, for it to initiate a bad reading or a failure prediction. So this tells me, the fact that there's data in here tells me the service I sent the original data to is going through machine learning, and it's being successfully processed, and then the result is getting stored back into the database. So I'm going to cut the video here, and I'm going to restart it and kind of go through the machine learning piece and some of the Azure portal stuff.